Imagine standing in complete darkness, 450 feet beneath the scorching Egyptian desert. The air is thick, ancient, and carries the weight of 4,500 years of silence. Your flashlight cuts through the blackness, illuminating massive granite blocks that fit together with surgical precision. You're inside the Great Pyramid of Giza, in chambers that were sealed when Rome was nothing more than a collection of mud huts. But here's what will make your blood run cold. The engineering you're witnessing shouldn't exist. Not according to everything we thought we knew about the ancient world. The block above your head weighs 70 tons. That's heavier than a fully loaded Boeing 737. It was quarried 500 miles away, transported across the desert, lifted 300 feet into the air, and positioned with an accuracy that modern construction crews struggle to match. And it was done by people who supposedly didn't even have the wheel. Welcome to the greatest engineering mystery in human history. For centuries, we've been asking the wrong question about the pyramids. We've wondered who built them, when they were built, even why they were built. But the question that will shatter everything you think you know about the ancient world is this: how were they built? Today, we're going to unlock the Pharaohs' greatest secret, not the treasure they hid, but the engineering knowledge they possessed. We're going to discover technologies that were supposedly impossible for their time, mathematical principles that wouldn't be discovered for another 1,000 years, and construction techniques so advanced that we're only now beginning to understand them. But I warn you, once you see what the ancient Egyptians were truly capable of, you'll never look at human history the same way again. Because the story we're about to tell isn't just about building pyramids. It's about a lost civilization that may have been far more advanced than we ever imagined. The pharaohs kept their secrets buried in stone for millennia. Today, we're going to unbury them. Let's start with something that should be impossible. The Great Pyramid of Giza covers 13 acres at its base. That's roughly 7 city blocks. But here's what defies explanation. The difference in length between the longest and shortest sides is less than 2 centimeters. That's smaller than the width of your thumb. To put this in perspective, imagine trying to build a structure the size of 7 city blocks and getting all 4 sides to match within 3/4 of an inch. With modern laser-guided equipment, GPS technology, and computer-controlled machinery, this would be considered excellent work. The ancient Egyptians did it with copper tools and rope, but that's just the beginning. The pyramid's base is level to within 2.1 centimeters across its entire 13-acre footprint. Modern construction projects consider themselves successful if they achieve levelness within several inches across such a massive area. The Egyptians achieved precision that's 10 times better. The orientation is even more mind-bending. The pyramid is aligned to true north with an accuracy of 3/60th of a degree. That's more precise than the magnetic compass, which wasn't invented until 2,000 years later. It's more accurate than many modern buildings. How did they achieve this level of precision without modern surveying equipment? But the real mystery lies in the internal structure. The king's chamber contains a granite sarcophagus that was carved from a single block of red granite, one of the hardest stones on Earth. The precision of the carving is extraordinary. The internal dimensions are accurate to within millimeters, and the surface finish is so smooth, it reflects light like a mirror. Here's what makes this impossible. Red granite has a hardness rating of 6 to 7 on the Mohs scale. The copper tools available to the ancient Egyptians have a hardness rating of 3 to 4. According to everything we know about material science, you cannot cut a harder material with a softer tool. It's like trying to cut steel with a butter knife. Yet the evidence is undeniable. The sarcophagus exists. The precision cuts exist. The tool marks exist. Somehow, the ancient Egyptians found a way to work granite with a precision that modern stone masons respect and admire. And this is just one chamber in one pyramid. The Great Pyramid contains millions of precisely cut and fitted stones. each one positioned with an accuracy that speaks to engineering knowledge we're only beginning to understand. The question isn't whether the ancient Egyptians achieved this precision. The evidence is standing in the desert for all to see. The question is how they did it. And that question is about to lead us into engineering secrets that will challenge everything we thought we knew about the ancient world. Hidden within the dimensions of the Great Pyramid lies a mathematical secret that shouldn't exist. The ratio of the pyramid's perimeter to its height is 2, a relationship that encodes the mathematical constant pi with an accuracy of 99.98%. This discovery should be impossible for a simple reason. Pi wasn't formally calculated to this level of accuracy until the 16th century. The ancient Egyptians built their pyramid 4,000 years earlier. How did they know about pi? How did they calculate it? And why did they encode it into their most important monument? But pi is just the beginning. The pyramid also encodes the golden ratio, that mystical proportion found throughout nature, from the spiral of nautilus shells to the arrangement of flower petals. The golden ratio appears in the pyramid's internal chambers, in the relationship between its height and base, and in the angles of its passages. The mathematical relationships go deeper. The pyramid's dimensions encode the radius and circumference of the Earth with startling accuracy. The height of the pyramid, when multiplied by 43,200, equals the polar radius of the Earth. The perimeter of the base, when multiplied by 43,200, equals the circumference of the Earth at the equator. These aren't approximations. They're precise to within a fraction of a percent. But here's what makes this impossible. The ancient Egyptians supposedly didn't know the Earth was round, let alone its exact dimensions. The circumference of the Earth wasn't accurately calculated until the 3rd century BCE, more than 2,000 years after the pyramid was built. Yet somehow, the pyramid builders encoded these measurements into their monument with mathematical precision that we can verify today using satellite technology. The internal chambers reveal even more mathematical sophistication. The Grand Gallery is built using a corbelled ceiling technique that distributes weight according to principles of structural engineering that weren't formally understood until the Renaissance. The angles of the internal passages align with specific stars and constellations, requiring sophisticated knowledge of astronomy and trigonometry. The Queen's Chamber contains shafts that extend at precise angles towards specific stars that were significant in ancient Egyptian religion. These aren't random tunnels. They're carefully calculated passages that demonstrate knowledge of stellar mechanics, precession, and the movement of celestial bodies across centuries. But perhaps most intriguing of all is the relationship between the pyramids, dimensions, and fundamental constants of physics. Some researchers have found relationships between the pyramid's measurements and the speed of light, the gravitational constant, and other physical properties of the universe. Whether these relationships are intentional or coincidental remains a matter of debate. But the sheer number of mathematical relationships encoded in the pyramid suggests a level of mathematical sophistication that challenges our understanding of ancient Egyptian capabilities. The question becomes, where did this mathematical knowledge come from? How did the pyramid builders acquire understanding of mathematical principles that wouldn't be formally discovered for thousands of years? And why did they consider it important enough to encode into their most enduring monument? Now let's talk about the sheer scale of what the ancient Egyptians accomplished. The Great Pyramid contains approximately 2.3 million stone blocks. If you were to build it today, using modern construction methods, it would require the coordination of multiple industries, international supply chains, and project management systems that didn't exist in the ancient world. But the ancient Egyptians didn't just build one pyramid, they built over 100 of them. The Giza complex alone represents one of the largest construction projects in human history, requiring the movement of over 6 million tons of stone and the coordination of tens of thousands of workers over several decades. Let's break down the logistics challenge. The limestone blocks for the pyramid's core came from local quarries, but the finest limestone for the outer casing came from Tura across the Nile River. The granite for the internal chambers came from Aswan 500 miles to the south. The basalt for some of the internal structures came from quarries even farther away. This means the pyramid builders had to coordinate multiple quarrying operations across hundreds of miles, transport millions of tons of stone across desert and river, and deliver everything to the construction site in the correct sequence and at the right time. Any delay or miscalculation would have brought the entire project to a halt. The transportation challenge alone should have been insurmountable. Moving a 15-ton granite block 500 miles across ancient Egypt required sophisticated understanding of logistics, engineering, and project management. They had to build roads, construct boats capable of carrying massive loads, and develop systems for loading and unloading stones that weighed as much as modern trucks. But the real challenge came at the construction site itself. The pyramid builders had to lift millions of tons of stone to heights of over 450 feet using only human power, ramps, and simple machines. The largest stones in the pyramid weigh 70 tons and are positioned near the top of the structure. Lifting a 70-ton block 400 feet into the air would be challenging with modern cranes. Doing it with Bronze Age technology seems impossible. Yet they did it. Not once, but repeatedly. The precision of the stone placement suggests that they had complete control over the lifting and positioning process. Stones that weigh tens of tons are fitted together with gaps so small that you can't slide a knife blade between them. The workforce required for such an undertaking was enormous. Conservative estimates suggest that the Great Pyramid required a workforce of 20,000 people during peak construction periods. But this wasn't just 20,000 random laborers. It was a highly organized, skilled workforce that included quarrymen, transporters, masons, engineers, surveyors, and administrators. Recent archaeological discoveries have revealed the infrastructure required to support this workforce. The workers' villages near the pyramids included bakeries capable of producing thousands of loaves of bread daily, breweries that produced beer for the workers, and medical facilities for treating injuries. The scale of the support infrastructure rivals that of a modern city. But perhaps most remarkably, the entire operation had to be coordinated without modern communication technology. There were no radios, no computers, no instant messaging. Coordination had to be achieved through human organization, planning, and management systems that we're only beginning to understand. The logistics of pyramid construction represent one of the greatest organizational achievements in human history. The fact that the ancient Egyptians pulled it off suggests capabilities that go far beyond what we typically associate with Bronze Age civilizations. Deep in the limestone quarries near Giza, archaeologists have uncovered evidence of quarrying techniques that challenge everything we thought we knew about ancient stone working. The precision of the cuts, the efficiency of the extraction, and the scale of the operation reveal engineering knowledge that was supposedly impossible for the time. The quarry faces show tool marks that are perfectly parallel, perfectly spaced, and perfectly consistent across hundreds of feet of rock face. These aren't the random hack marks you'd expect from primitive tools. They're the systematic, precise cuts of advanced quarrying techniques. But here's what makes it impossible. The tool marks show evidence of cutting techniques that require tools harder than the stone being cut. Limestone has a hardness of about 3 to 4 on the Mohs scale. The copper tools available to the ancient Egyptians have a similar hardness. You cannot efficiently cut limestone with copper tools alone. Yet the evidence shows that the ancient Egyptians were cutting limestone blocks with a precision and efficiency that modern quarries would envy. Some of the blocks show evidence of being cut in a single operation, with no evidence of the multiple cuts and finishing work that would be required with primitive tools. Recent analysis of the tool marks has revealed something even more intriguing: evidence of cutting speeds that shouldn't be possible with hand tools. The spacing and depth of the tool marks suggest cutting rates that would require either powered tools or cutting techniques that we don't understand. The granite quarries at Aswan reveal even more puzzling evidence. Granite is one of the hardest stones on Earth, with a hardness rating of 6 to 7 on the Mohs scale. Working granite with copper tools should be virtually impossible, like trying to cut steel with aluminum. Yet the Aswan quarries show evidence of granite cutting on an industrial scale. The famous unfinished obelisk at Aswan weighs over 1,000 tons and shows evidence of cutting techniques that modern stone workers struggle to understand. The cuts are perfectly straight, perfectly smooth, and show no evidence of the fracturing and chipping that would be expected from primitive cutting methods. Some of the granite blocks show evidence of drilling perfectly round holes that extend deep into the stone with walls that are smooth and parallel. The drill marks show a spiral pattern that suggests rotary drilling, but rotary drills weren't supposed to exist in ancient Egypt. Even more puzzling are the saw marks found on some granite blocks. These aren't the rough cuts you'd expect from copper saws, they're smooth, precise cuts that show evidence of cutting rates that would require diamond-tipped saw blades. The cuts are so precise that they show no evidence of wandering or deviation, suggesting a level of control that should be impossible with hand tools. The quarrying evidence suggests that the ancient Egyptians possessed cutting and drilling technologies that were far more advanced than anything we associate with Bronze Age civilizations. Whether these technologies involved unknown techniques, lost tools, or methods we haven't yet understood remains a mystery. But the evidence is undeniable. The ancient Egyptians were cutting and shaping some of the hardest stones on Earth with a precision and efficiency that challenges our understanding of their technological capabilities. Moving millions of tons of stone across ancient Egypt required transportation technologies that shouldn't have existed. Recent archaeological discoveries have revealed evidence of transportation systems that were far more sophisticated than the simple sleds and ramps typically depicted in textbooks. The first clue came from the discovery of ancient harbor installations near the pyramids. These weren't simple docking areas. They were sophisticated port facilities with stone-lined channels, loading ramps, and infrastructure for handling massive loads. The engineering of these harbors suggests knowledge of hydraulics, water management, and heavy lifting that was supposedly unknown in the ancient world. But the real revelation came from the discovery of the Wadi al-Jarf papyri ancient logbooks that document the Pook, transportation of limestone from the Tura quarries to the Giza pyramids. These documents reveal a transportation system that was far more sophisticated than anyone had imagined. The papyri describe boats capable of carrying loads of 3,040 tons, massive vessels that would have been among the largest ships in the ancient world. But these weren't just big boats. They were specialized vessels designed specifically for transporting stone blocks. The documents describe loading and unloading procedures, navigation techniques, and coordination systems that reveal sophisticated understanding of marine engineering. The boats themselves had to be engineering marvels. Carrying 30 to 40 tons of stone requires not just a large vessel, but one designed to handle the stress of such massive, concentrated loads. The boats had to be strong enough to carry the weight, stable enough to navigate safely, and maneuverable enough to dock at specific locations. But water transportation was only part of the challenge. Once the stones reached the pyramid site, they had to be moved from the harbor to the construction area and then lifted to their final positions. This required land transportation systems that were equally sophisticated. Recent discoveries have revealed evidence of road systems that were far more advanced than simple dirt paths. These roads were engineered surfaces designed to handle heavy loads, with foundations, drainage systems, and maintenance protocols that ensured they could support the massive transportation requirements of pyramid construction. The roads show evidence of engineering principles that weren't supposed to be known in the ancient world. They're graded to specific angles to minimize the effort required to move heavy loads. They include drainage systems to prevent washouts during flood seasons. They're built with materials and techniques that ensure durability under extreme stress. But perhaps most intriguing are the recent discoveries of what appear to be ancient railways, stone tracks with grooves designed to guide wheeled vehicles. These discoveries challenge the conventional wisdom that the ancient Egyptians didn't use wheeled transportation for heavy loads. The stone tracks show evidence of wear patterns consistent with repeated use by heavy vehicles. The spacing of the tracks suggests standardized vehicle designs. The engineering of the track systems shows understanding of load distribution, friction reduction, and transportation efficiency that was supposedly unknown in the ancient world. Some researchers have suggested that these tracks were used with vehicles that combined wheels with other transportation methods, perhaps sleds that could be converted to wheeled vehicles depending on the terrain. Such hybrid transportation systems would represent a level of engineering sophistication that challenges our understanding of ancient Egyptian capabilities. The transportation evidence suggests that the ancient Egyptians developed technologies and systems that were far more advanced than anything we typically associate with Bronze Age civilizations. Whether these technologies were unique to Egypt or represent lost knowledge that was more widespread remains an open question. Now we come to perhaps the greatest engineering mystery of all. How did the ancient Egyptians lift millions of tons of stone to heights of over 450 feet using only human power and simple machines? The conventional explanation involves ramps, long sloping surfaces that would allow workers to drag stones to higher levels. But when you actually calculate the requirements for such ramps, the conventional explanation falls apart. A straight ramp to the top of the Great Pyramid would need to be over a mile long to maintain a reasonable slope. Such a ramp would require more material than the pyramid itself and would cover an area larger than the entire Giza plateau. It's simply not feasible. Spiral ramps that wrap around the pyramid are more feasible, but they create their own problems. How do you turn a 15-ton block around a corner? How do you maintain structural integrity as the ramp gets higher and narrower? How do you provide enough working space for the teams of workers required to move such massive loads? Recent archaeological discoveries have revealed evidence of ramp systems that were far more sophisticated than simple sloping surfaces. These weren't just dirt ramps. They were engineered structures with foundations, retaining walls, and sophisticated support systems. But even more intriguing is evidence that suggests the ancient Egyptians may have used lifting technologies that we don't fully understand. Some researchers have found evidence of what appear to be ancient counterweight systems, massive stone weights that could be used to help lift heavy loads. The evidence includes stone blocks with precisely cut channels and holes that could have been used for rope and pulley systems. Some of these blocks show wear patterns consistent with repeated use as part of lifting mechanisms. The precision of the cuts and the engineering of the attachment points suggests sophisticated understanding of mechanical advantage and load distribution. Even more puzzling are discoveries of what appear to be ancient crane stone structures with precisely engineered pivot, points, and attachment systems. These structures show evidence of being designed to handle massive loads and could represent lifting technologies that were far more advanced than anything we associate with the ancient world. Some of the lifting evidence suggests the use of hydraulic systems using water pressure to help lift heavy loads. Ancient texts describe the use of water-filled chambers and channels in construction projects, and some researchers have interpreted this as evidence of primitive hydraulic lifting systems. The internal structure of the pyramids themselves provides clues about lifting techniques. The precision with which massive stones are positioned in the upper chambers suggests lifting systems that provided extraordinary control and accuracy. Some stones weighing tens of tons are positioned with millimeter precision, a level of control that would be challenging even with modern cranes. The Grand Gallery in the Great Pyramid may itself have been part of a sophisticated lifting system. Some researchers have suggested that the gallery's unique design with its corbelled ceiling and precisely engineered dimensions was intended to house a massive counterweight system that could lift stones to the upper chambers. The lifting evidence suggests that the ancient Egyptians developed technologies and techniques that were far more sophisticated than simple ramps and human muscle power. Whether these technologies involved mechanical systems, hydraulic systems, or techniques we haven't yet understood remains one of the greatest mysteries of ancient engineering. Once the stones reached their destination, they had to be positioned with a precision that defies explanation. The accuracy of stone placement in the pyramids represents one of the greatest achievements in construction history and one of the greatest mysteries. The stones in the pyramid's core are fitted together with gaps so small that you can't slide a piece of paper between them. This level of precision would be impressive in modern construction. Achieving it with Bronze Age tools seems impossible. But the precision goes beyond just tight fits. The stones are positioned with mathematical accuracy that suggests sophisticated surveying and measurement techniques. The internal chambers are positioned with millimeter precision relative to the pyramid's overall structure. The passages are aligned with astronomical accuracy that requires understanding of celestial mechanics. The precision of the stone cutting is equally mysterious. Each stone had to be cut to exact dimensions to fit its specific position in the structure. This wasn't mass production, it was custom fabrication on an enormous scale. Each of the 2.3 million stones in the Great Pyramid was individually shaped to fit its precise location. The tool marks on the stones show evidence of cutting techniques that achieved surface finishes comparable to modern machine work. Some stones have surface finishes so smooth that they reflect light like mirrors. The precision of the angles and dimensions rivals modern manufacturing tolerances. But perhaps most puzzling is the evidence of what appears to be standardization. Despite being individually cut, many stones show evidence of standardized dimensions and proportions. This suggests manufacturing systems that could produce consistent results across millions of individual pieces, a level of quality control that shouldn't have been possible without modern measurement and manufacturing techniques. The internal chambers reveal even more precision mysteries. The king's chamber is built to dimensions that are accurate to within millimeters. The walls are perfectly vertical, the corners are perfectly square, and the ceiling is perfectly level. The chamber's acoustics suggest that even sound properties were considered in its design. The sarcophagus in the king's chamber represents perhaps the ultimate precision achievement. Carved from a single block of red granite, it has internal dimensions that are accurate to within fractions of millimeters. The surface finish is so smooth that it appears to have been polished with modern abrasives. The precision of the carving suggests cutting and finishing techniques that we don't fully understand. Recent analysis using laser scanning technology has revealed that the precision of pyramid construction exceeds what was previously thought possible. The overall structure deviates from perfect geometric form by amounts so small that they're within the margin of error of modern surveying equipment. The precision evidence suggests that the ancient Egyptians possessed measurement, cutting, and positioning technologies that were far more advanced than anything we associate with Bronze Age civilizations. Whether these technologies involved unknown tools, lost techniques, or methods we haven't yet understood remains one of the greatest mysteries of ancient engineering. The level of precision achieved in pyramid construction represents a standard of excellence that modern construction projects struggle to match. It suggests a culture that valued accuracy and perfection to a degree that seems almost obsessive by modern standards. Behind every stone, every measurement, every precisely cut block was an organizational system that may represent the greatest achievement of ancient Egyptian engineering, the ability to coordinate the efforts of tens of thousands of people across decades of construction. Recent archaeological discoveries have revealed the infrastructure of this organizational system, and it's far more sophisticated than anyone imagined. The workers' villages near the pyramids weren't simple camps. They were planned communities with specialized facilities, administrative centers, and support systems that rival modern construction projects. The bakeries alone represent an engineering marvel. To feed 20,000 workers, the Egyptians built industrial-scale bread production facilities with sophisticated ovens, grain storage systems, and distribution networks. The ovens were designed for efficiency and consistency, with temperature control systems and production capacities that could produce thousands of loaves daily. The brewery systems were equally sophisticated. Beer was a staple of the ancient Egyptian diet, and the pyramid builders developed brewing systems that could produce beer on an industrial scale. The brewing facilities show evidence of quality control systems, standardized recipes, and distribution networks that ensured consistent supply to the workforce. But the real organizational genius lay in the coordination systems. The pyramid builders had to coordinate multiple quarrying operations, transportation networks, construction teams, and support services across hundreds of miles and decades of time. This required planning, communication, and management systems that were far more sophisticated than anything we associate with the ancient world. Recent discoveries of ancient papyri have revealed the administrative systems behind pyramid construction. These documents show evidence of sophisticated record-keeping, resource allocation, and project management techniques. The Egyptians tracked materials, monitored progress, and coordinated activities with a level of detail that rivals modern project management systems. The papyri reveal hierarchical management structures with specialized roles and responsibilities. There were overseers for different aspects of construction, administrators for different types of resources, and coordinators for different phases of the project. The organizational chart for pyramid construction would look familiar to any modern project manager. But perhaps most impressive was the quality control system. The precision of pyramid construction wasn't achieved by accident. It was the result of systematic quality control, processes that ensured every stone met exact specifications. This required inspection systems, measurement standards, and correction procedures that maintained accuracy across millions of individual components. The workforce management systems were equally sophisticated. The Egyptians had to recruit, train, house, feed, and coordinate tens of thousands of workers with different skills and specializations. This required human resource systems, training programs, and management techniques that were far more advanced than anything we typically associate with ancient civilizations. The evidence suggests that the pyramid builders developed management and organizational technologies that were far ahead of their time. These weren't primitive people struggling with simple tasks. They were sophisticated managers, coordinating complex operations with efficiency and precision that modern organizations would envy. The organizational systems behind pyramid construction may represent one of humanity's earliest examples of large-scale project management, industrial organization, and systematic quality control. The techniques and principles they developed would not be seen again until the Industrial Revolution, over 4,000 years later. As we piece together the evidence from quarries, transportation systems, construction sites, and organizational records, a startling picture emerges. The ancient Egyptians possessed technologies that were far more advanced than anything we associate with Bronze Age civilizations. Some of these technologies challenge our fundamental understanding of ancient capabilities. The precision cutting of granite, the transportation of massive loads, the lifting of stones to extraordinary heights, the organizational coordination of massive projects. All of these achievements suggest technological capabilities that seem impossible for their time. But what were these technologies? How did they work? And why did they disappear from the historical record? Recent research has begun to uncover evidence of technologies that were far more sophisticated than previously imagined. The cutting evidence suggests tools and techniques that could work the hardest stones with precision that rivals modern machinery. The transportation evidence suggests vehicles and systems that could move massive loads with efficiency that modern logistics would respect. The lifting evidence suggests mechanical systems that could raise enormous weights to extraordinary heights with precision that modern cranes would struggle to match. The organizational evidence suggests management and coordination systems that could orchestrate complex operations with efficiency that modern project management would admire. Some researchers have suggested that the ancient Egyptians developed technologies that were later lost during periods of political instability and cultural change. The knowledge may have been concentrated among specialized groups of engineers and craftsmen who took their secrets to their graves when their civilization declined. Others have suggested that the technologies were deliberately concealed, that the pyramid builders considered their engineering knowledge to be sacred secrets that should not be shared with outsiders. The precision and sophistication of their achievements may have been seen as divine gifts that required protection and secrecy. Still others have suggested that the technologies were so specialized and context-specific that they couldn't be easily transferred to other applications. The techniques that worked for pyramid construction may not have been useful for other types of projects, leading to their gradual abandonment as construction priorities changed. But perhaps the most intriguing possibility is that the ancient Egyptians developed technologies that we simply don't understand yet. Modern engineering is based on principles and assumptions that may not apply to ancient techniques. The Egyptians may have discovered ways of working with materials, organizing labor, and coordinating complex projects that we haven't yet figured out. Recent experimental archaeology has begun to explore some of these possibilities. Researchers are attempting to recreate ancient techniques using only tools and materials that would have been available to the pyramid builders. Some of these experiments have produced surprising results, suggesting that ancient techniques may have been more sophisticated than we realized. The lost technologies of pyramid construction represent one of the greatest mysteries in engineering history. Whether these technologies involved unknown tools, lost techniques, or principles we haven't yet understood, they clearly enabled achievements that challenge our understanding of ancient capabilities. The search for these lost technologies continues, driven by the recognition that understanding how the pyramids were built may reveal engineering principles and techniques that could be useful today. In recent decades, modern technology has begun to unlock secrets of pyramid construction that have been hidden for millennia. Advanced scanning techniques, materials analysis, and computer modeling are revealing engineering details that were invisible to earlier investigators. Ground-penetrating radar has revealed hidden chambers and passages within the pyramids, suggesting that the internal structure is far more complex than previously realized. These discoveries are forcing archaeologists to reconsider their understanding of pyramid design and construction techniques. Laser scanning technology has mapped the pyramids with unprecedented precision, revealing construction details that were invisible to the naked eye. The scans show that the precision of pyramid construction exceeds what was previously thought possible, with deviations from perfect geometric form that are smaller than the margin of error of modern surveying equipment. Materials analysis using advanced spectroscopy and chemical analysis has revealed details about the stones used in pyramid construction. The analysis shows that the Egyptians selected materials with specific properties for specific applications, suggesting sophisticated understanding of materials science that was far ahead of its time. Computer modeling has allowed researchers to test different theories about pyramid construction techniques. These models can simulate the stresses and forces involved in moving and lifting massive stones, helping to identify which techniques would have been feasible and which would have been impossible. Some of the most intriguing discoveries have come from cosmic ray imaging, a technique that uses naturally occurring cosmic rays to create images of the internal structure of the pyramids. This technology has revealed previously unknown voids and chambers within the Great Pyramid, suggesting that our understanding of its internal structure is still incomplete. The cosmic ray imaging has revealed a large void above the Grand Gallery that appears to be a previously unknown chamber. The purpose of this chamber remains a mystery, but its discovery suggests that the pyramids may contain engineering features that we haven't yet understood. Acoustic analysis has revealed that the internal chambers of the pyramids have remarkable acoustic properties. The chambers appear to have been designed to enhance certain frequencies and dampen others, suggesting that sound properties were considered in their design. Some researchers have suggested that the chambers may have been designed as resonating chambers for specific acoustic effects. Thermal imaging has revealed temperature variations within the pyramid structure that suggest the presence of hidden chambers and passages. The thermal signatures show patterns that are consistent with air circulation systems and internal spaces that aren't visible from the outside. Seismic analysis has revealed details about the internal structure and foundation systems of the pyramids. The seismic data shows that the pyramids are built on sophisticated foundation systems that distribute their enormous weight across the underlying bedrock with remarkable efficiency. All of these modern investigations are revealing that the pyramids are far more sophisticated than previously realized. The engineering involved in their construction appears to have been more advanced, more precise, and more complex than anything we associate with Bronze Age civilizations. The modern investigations are also revealing that our understanding of pyramid construction is still incomplete. Each new discovery raises new questions and suggests new mysteries that remain to be solved. As we piece together the evidence from ancient quarries, transportation systems, construction sites, and modern investigations, we're forced to confront a startling possibility. The ancient Egyptians may have possessed engineering knowledge and technological capabilities that were far more advanced than we ever imagined. This possibility has profound implications for our understanding of human history, technological development, and the capabilities of ancient civilizations. If the pyramid builders possessed advanced technologies, what happened to that knowledge? Why did it disappear? And what else might ancient civilizations have achieved that we don't yet understand? The precision evidence suggests that the ancient Egyptians developed measurement and manufacturing techniques that weren't seen again until the Industrial Revolution. The transportation evidence suggests logistics and engineering capabilities that rival modern systems. The organizational evidence suggests management and coordination techniques that modern project managers would respect. But perhaps most intriguingly, the mathematical evidence suggests that the ancient Egyptians possessed knowledge of mathematical and physical principles that weren't formally discovered until thousands of years later. The encoding of pi, the golden ratio, and Earth's dimensions in the pyramid structure suggests understanding of mathematics and astronomy that was far ahead of its time. This raises fundamental questions about the nature of technological development. We typically think of technology as developing in a linear progression, with each generation building on the achievements of the previous one. But the pyramid evidence suggests that technological development may be more complex than we realize. It's possible that ancient civilizations achieved technological capabilities that were later lost during periods of political instability, cultural change, or natural disasters. The knowledge may have been concentrated among small groups of specialists who took their secrets to their graves when their civilizations declined. It's also possible that ancient civilizations developed technologies that were so different from our own that we don't recognize them as advanced. Our understanding of technology is based on our own cultural assumptions and historical experience. Ancient technologies may have followed different principles and approaches that we haven't yet understood. The pyramid evidence also raises questions about the relationship between technology and civilization. We typically assume that advanced technology requires complex industrial infrastructure and widespread scientific knowledge. But the pyramids suggest that remarkable technological achievements may be possible with different organizational structures and knowledge systems. Perhaps most importantly, the pyramid evidence challenges us to reconsider our assumptions about human capabilities. The precision, scale, and sophistication of pyramid construction suggest that human beings may be capable of far greater achievements than we typically imagine, even with relatively simple tools and technologies. The pyramid builders achieved their remarkable results not through advanced machinery, but through advanced knowledge, sophisticated organization, and unwavering commitment to excellence. They show us that the most important technologies may not be mechanical, but intellectual and organizational. The implications of pyramid construction extend far beyond archaeology and ancient history. They challenge us to think differently about human potential, technological development, and the possibilities for achievement in our own time. As we stand once again in the shadow of the Great Pyramid, we're left with a profound appreciation for the achievement it represents, and a humbling recognition of how much we still don't understand. The pyramid is more than just a monument to a dead pharaoh. It's a testament to human ingenuity, organizational capability, and the relentless pursuit of perfection. It represents the pinnacle of what people can achieve when they combine knowledge, skill, determination, and vision. But it's also a reminder of how much knowledge has been lost over the millennia. The techniques that enabled such precision, such scale, such sophistication have largely disappeared from the historical record. We can see the results of their work, but we can only guess at the methods they used. The Pharaoh's secret wasn't hidden treasure or mystical powers. It was engineering knowledge that enabled them to create one of the most enduring monuments in human history. They possessed understanding of mathematics, material science, logistics, and organization that was far ahead of its time. This knowledge enabled them to achieve precision that rivals modern manufacturing, to coordinate projects that rival modern logistics, and to create structures that have outlasted empires and civilizations. The Great Pyramid has stood for 4,500 years and will likely stand for thousands more. But the greatest secret of the pyramid builders may be the most simple and the most profound. They believed that human beings were capable of achieving the impossible. They set goals that seemed beyond reach and then developed the knowledge, techniques, and organization necessary to achieve them. The pyramid stands as proof that they were right. Human beings, working together with sufficient knowledge and determination, can accomplish things that seem impossible. The precision, scale, and sophistication of pyramid construction show us what we're capable of when we set our minds to it. The engineering behind the giant pyramids remains one of the greatest mysteries in human history. We may never fully understand all the techniques and technologies that enabled their construction, but we can appreciate the achievement they represent and the lessons they teach us about human potential. The pharaohs built their pyramids to last for eternity, and in that goal, they succeeded. But their greatest achievement may not be the monuments themselves, it may be the inspiration. They provide for future generations to attempt the impossible and achieve the extraordinary. As modern technology continues to reveal new secrets about pyramid construction, we may eventually understand the full extent of ancient Egyptian engineering capabilities. But even if we solve all the technical mysteries, the pyramids will continue to inspire us with their testament to human achievement. The Pharaoh's secret is ultimately our secret, the knowledge that human beings, working together with vision and determination, can create things that outlast civilizations and inspire wonder across millennia. The pyramids stand as eternal proof of what we're capable of when we dare to attempt the impossible. In the end, the greatest engineering achievement of the pyramid builders may not have been the monuments they created, but the example they set for all who came after them. They showed us that the only limits on human achievement are the limits we place on ourselves. The pyramids will continue to stand in the desert, keeping their secrets and inspiring new generations to push the boundaries of what's possible. They remind us that the greatest engineering challenges aren't technical, they're human. The pharaoh's greatest secret was their belief in human potential, and that secret remains as relevant today as it was 4,500 years ago.